The purpose of a power amplifier is to make sound louder. To some extent, it's as simple as that. A well-made and probably more costly amplifier will amplify sound better and be less distorted than a less expensive unit. And a bigger, in terms of output power, amplifier will amplify sound louder than an amplifier with a lower rating. So what's the mystery? What are the issues? Well, one issue is that people tend not to realise how important amplification is. A good power amplifier will make your sound clean, clear and punchy, make it come alive. An inexpensive amplifier, or one that's not compatible with the rest of your system, can make your sound weak and dull, or at worst, completely fail to operate. You'll find this usually happens right in the middle of your performance. And after all the work you did learning how to play your instrument and learning the songs. Yup, amplification is that important. Power amplifiers are not the stuff of dreams in the looks department. Here you have a power switch, a series of LEDs to warn you about the temperature of the amp, and whether it's in protection mode to prevent overheating or damage to your loudspeakers. A typical 2-channel amp has attenuators for each of the amp's A and B channels, plus other LEDs for clipping and signal, i.e. is it on. Finally, you can see air intake grills for the forced air cooling system. From this you can probably see that heat is obviously a key issue for a power amplifier. Indeed, any electrical device that generates power, from a power amplifier to a light bulb, generates heat as a byproduct. This heat is unavoidable, but it is the sworn enemy of the electronic circuits in the amplifier, so dealing with this heat is extremely important. In the first place, Yamaha designs its amplifiers to be as efficient as possible to reduce heating. But by properly matching the amplifier to the loudspeakers it'll be driving, you'll definitely be able to avoid trouble. Let's back up a minute and look at the causes of this heat. The key parameter of a power amp is its power output rating, basically how loud it'll go. Power rating is measured in watts, but wattage is only part of the picture. 200 watts may be twice the electrical power of 100 watts, but actually loudness or acoustic power follows a logarithmic scale, meaning every time you double the volume, a 10 times increase in electrical power is required. So to double the volume difference of 100 watts, you would actually need 1000 watts, which is why there are so many high-powered amplifiers to choose from. The delivery of power is one thing. How loudspeakers receive and handle that power is the other factor you have to consider. And this is a question of the impedance of the loudspeaker, which is measured in units called ohms. The relationship between watts and ohms sounds like a detective story, doesn't it? Not only determines how loud your system will be, but also whether or not your amplifier's heating will be manageable. Impedance is a measure of resistance that the loudspeaker system presents to the amplifier. Higher impedance will translate to lower wattage, while lower impedance means higher wattage. A lot of amplifier advertisements, you see, have power ratings done at very low impedances, which makes it look good on paper, but actually is pretty misleading about the actual usable power that you're going to have at your disposal. So why not have all loudspeakers running at super low impedances? As with most things in life, there is a balance. If the loudspeakers have impedance ratings that are too low, the amplifier might not be able to effectively power the system without generating too much of its number one enemy, heat. And if the impedance is too high, the path the signal flows through will be too restricted. All of the professional loudspeaker systems that Yamaha makes have nominal impedances of either 4 or 8 ohms, and that makes them perfect for use with most of the amplifiers on the market today, and we'll cover them later in the program. As a matter of fact, most professional sound companies do not operate systems with impedances of less than 4 ohms, again, mainly to avoid the heating and risk of failure.
If we were to measure a piece of wire with a meter, we would show 0 ohms. It'd be a dead short. It would go right through. A speaker, typically the one I'm talking about, has 8 ohms, so it has some resistance. If I put an 8 ohm speaker next to an 8 ohm speaker and I put them in parallel, I'm going to get a 4 ohm load, which means it's going to be closer to a dead short than just the one 8 ohm speaker. So can I put 2 speakers on an amplifier? Sure. Can I put more? Can I put 3? Can I put 4? Why not put 20? Well, the more speakers I put on there, obviously the closer I approach that 0 or that dead short. If I take 2 8 ohm speakers and I put them together, I have a 4 ohm load. If I take 2 more 8 ohm speakers and I have this 4 ohm load and I put them together, I'm going to get a 2 ohm load. If I do it again, I'm going to drop down, and so forth and so on.
I see.
You're never going to get to 0, but you're going to get close. The amplifier, as you drop the impedance, increases in operating temperature, and it also increases its distortion. Most amplifiers are designed to do 4 or 8 ohms. So the closer I get to this 0 point, which theoretically can't happen, the more distortion I'm going to get, and the amplifier is running quite a bit more unstably than it otherwise would. So you want to avoid 2 ohm loads. You really do.
Amps come in 2 basic flavours, single channel and 2 channel. And a 2-channel amp can use their 2 channels in a few different ways. 1. In stereo mode. This powers a full left-right system, or as 2 individual mono amps, one say for your main speakers and the other for your monitor system. 2. In parallel. This is where one input signal is fed to both amplifier channels. Use this to send the same signal to 2 different loudspeaker systems, and still use the attenuators for level control. 3. Bridge mode, where each channel's power is combined into one giant mono output, effectively doubling the power being delivered to a single set of outputs. This mode is generally used for subwoofers and large speaker systems. Is that the end of the story? Not quite. One amplifier will not necessarily do everything you need. If you're running a full monitor system, for instance, you'll probably want to use a separate amp channel to power it. Also, if you're running a multiple speaker setup, like main speakers plus subwoofers, you'll need separate amplification for each, plus another piece of equipment called a crossover. A crossover is a series of filters that splits a full range signal into different frequency bands that loudspeakers are designed to reproduce. Some loudspeaker units have what's called a passive crossover already built into them, and that distributes its signals to its low and high frequency drivers and horns respectively. And we'll look at these more closely in the loudspeaker scene. An active crossover, on the other hand, as its name implies, gives you control over the frequency ranges that are being sent to each of the components. In other words, your subwoofers just get the lows, and your mains just the mids and highs. Some amplifiers, like the Yamaha P series, have an active crossover built in. This kind of saves both money and cabling hassles. Here on the Yamaha P3500S, you can see these crossover style filtering controls at the back. Amplifiers don't produce power. They convert power from an AC outlet. High-powered amplifiers can draw large amounts of AC power, so be sure to use heavy cabling and avoid power strips, as these will limit the amount of current available to the amplifier. Make sure amplifiers don't overheat, and that they have plenty of ventilation. Remember, heat is enemy number 1 for power amplifiers. Drive amps hard, but not to the max. Professional power amplifiers are made to deliver a very high output. An occasional clip light flashing is your indication that you've reached that maximum output of the amplifier. Distortion damages your speakers, your ears, and is pretty hard on the audience's ears as well. Avoid this by controlling your maximum output levels. Don't skimp on cabling. Use large gauge wiring to assure that all the power the amplifier provides actually goes to the loudspeaker. You should also eliminate excessive extra length. If your cables are too long, you're wasting some of that power that could be getting to the loudspeaker.
We always try to minimize the amount of cable between the speaker and the amplifier because they sound better. There's no reason to waste your amplifier power heating up the copper in the cable. You want to basically get your amplifiers as close to the speakers as you can. Sometimes when you can't, you need to use the 150s, but anytime you can use the 5 or the 10 footers, it's really the best thing to do.